Okay, in this problem, we are given that there's a national election in which there are two candidates, A and B, that are running for office, and 52% of the population is in favor of candidate A. And then we take a random sample of 1,200 registered voters, that's our sample size, which reveals that 588 out of that 1,200 are in favor of candidate A. So, in order to work this problem, the variable of interest, I could scroll back to that, as we look at the problem, is whether the voter favors candidate A. That's what we're looking for. This is a sampling distribution, is approximately normal for a couple of reasons here. We do these two tests. One is that the sample size at 1,200 is less than 5% of the population of the country. And the second test is when we multiply n times p times, and I call this 1 minus p, I call that q. But anyway, n times p times q, we get 299.52, which is greater than or equal to 10. Okay, so p is 0.52, q is going to be 0.48. So then we've got a question here. The mean of the sampling distribution of the sample proportion is 0.52, okay, because they tell us that in the problem. They don't, however, give us the standard deviation, but we know how to find the standard deviation because we're told for a p-hat distribution, we've got this little formula. The standard deviation of a p-hat distribution is equal to the square root of p times q all over n, the sample size. So if I plug in my numbers here, I've got the square root of 0.52 times 0.48 divided by the sample size. And in this case, the sample size was that 1,200. And when I do that arithmetic, plug that into my calculator, then this is the answer I get, 0.0144. Now, if I want to find the probability that x is less than or equal to 588, we can change that to a p-hat by taking that proportion, 588 divided by 1,200, which is 0.49. And then we find our answer here for the second part of this by going to our, I'm going to use StatCrunch. So if we go to StatCrunch and look at our calculator for normal, we're going to use as our mean, the mean for this distribution was 0.52, because the mean for the sampling distribution is the same thing as the mean for the population. The sample standard deviation we found, 0.0144. And we're looking at the probability that x is less than 588, as actually 588, p-hat is 588 divided by 1,200. So we're going to use 0.49. And when we compute, we get 0.0186. Okay. Then as we go down in the next part of this, notice that this part here was, we're considering, how can I put it, that 2% of the time we would expect this to happen, that 2 times out of 100, we expect to have 588 or fewer voters that are in favor of candidate A. I hope this helps.